A few years ago, we realized here at Intel that it's very important to be able to measure and quantify and predict people's experience when they're using their computing device. We started working with real people collecting the data, and now we're able to take that database of information and be able to predict reliably and accurately what real people would say about the way various devices act. Oculus allows us to repeatedly measure things that we know people will love. We can measure touch experience, we can measure auditory experience, we can measure viewing angles on a screen, so we can provide a target to the engineers.
So here we have our Oculus setup. It consists of a robotic arm to evaluate user experiences. So anything a user would do with the device, we want to replicate. And we want the robot to do it. And the reason we want the robot to do it is because it's repeatable. It can do it again and again. We're going to get consistent results, but also it's controlled.
We've created our devices so that we can quantify the sweet spot of experience, so that we can really see where the average person is going to love that experience. They're really going to get into it, be immersed into it, and enjoy every minute of what they're doing.
One of the most important factors affecting a user experience on a device is the display. It's the one thing on top of everything that you're doing. So with this device right here is a spectroradiometer, and it measures emitted wavelength from a device. So we will measure how accurate those colors are versus what you expect to see, like from a digital camera or from a video file. We look at viewing angle as well. This device allows us to measure all of the light coming out of a device at once. So here you'll see this crosshair pattern is indicating that vertically and horizontally the device is pretty uniform, but as you tilt it off to the side, say if you're trying to show a movie to a friend, you might not be able to see that movie as well.
Well, here we are in a hemianechoic chamber. We use this chamber as a control. It's very quiet in here so that we can test our speech recognition and call quality. Then we have a background noise simulator that allows us to put our head and torso simulator sonically in different locations and see how devices react.
Real people are the priority. Our Oculus tools provide a wide range of things that we can measure, and then we can take those responses, feed them back to our engineering audience, and the engineers can then go out and design a device that's going to meet exactly those requirements. Our Oculus tools allow us at this time to measure 3 of the 5 senses. We have touch, we have sight, we have sound. We don't really have smell or taste yet, but again, I guess we're not really using those with our computing devices today.